Thanks. So let's begin. I am Umang. I am a generalist open source software developer for a couple of years now. Recently, uh, I am working on a project called Libcamera. I don't think I have camera right now. That's ironic. Yeah, I don't have a webcam right now. Sorry, it's. I thought it could go with presentation and audio only. Uh, yeah. So is that okay? I guess so. Okay, sure. Thanks. So let's begin. So I'm. Let's uh, talk about the like video capture Linux media domain for a while. What happens is like a while ago, like 10 to 15 years ago, there was the Linux media and the video capture domain was quite simple. You would have a camera sensor at the top, and there uh, would be an interface, CSI2 or even parallel, and that would get exposed through a video node. So writing applications, user space applications, was pretty easy. You would have only one place for control, one place to look for frames, and just display it to your output window. So this was basically very simple, and it worked well for a while, but then things get complicated. Yeah, so complexity increased with image signal processors being introduced. So let's talk a bit brief about what are ISPs, or image signal processors. They are system peripherals. That means they are operating at very high frequency that operate on a digital images. So basically the raw data captured by the sensor is then pushed down to ISPs, and they do some stuff that we are going to talk. So basically DMA, resizing, scaling, cropping, or pixel format conversion are some of the things that they would do. These are the basic ones that basically were found in many, but there are other ISPs. So ISPs is basically a group of building blocks that have some specific operations on the raw data that been captured. So imagine a pipeline, or simply a GStreamer pipeline. You would have elements and the data would flow through them. So image signal processors were then, but they are basically system peripherals. So they were like embedded on the SoC itself. So in order to manage the data flow through these peripherals, kernel exposed a new API named Media Controller. Before that, to capture like the video frames and all, there was already an API called V4L, Video for Linux, and V4L2. So that part was sorted, but the introduction of ISPs led to a need to introduce a new API called Media Controller in the kernel. So looking at high level, what exactly has happened? I cannot see my slide. Okay, so yeah, the hardware topology got complicated, like you can see here. You would have some sensors. The red boxes are the sensors, like two sensors and a flash maybe. The ISP's building blocks are denoted in green. So you would have some subdevs, something resizer, and the blue boxes are the API. So mind you, these are the video nodes. They are also configured. They are also interfaced with an API, maybe V4L, and the ISPs were controlled using something we discussed as media controller. So two different APIs to manage the video capture here. Okay, so looking at very high level for a camera application, earlier it was just V4L2, one place to look for frames, one place to control them. And now with the introduction of complex ISPs, you would have V4L2, you would, the camera application would also need to know about media controller, like how media will flow through the peripherals, subdev. So it became a very complex task to write a camera application without the knowledge of like hardware complexity you are handling. And being very tied to a hardware is something which does not scale in the long run. So this went for a while in embedded, and like you have seen, like the mobiles and the cell phones had cameras which are which use basically this this framework, or like practice more as to say. But since last couple of years, those cameras are slowly coming to the personal computing world, the laptops, and few other like UVC devices and all. So we need to address a problem here. We need like something which can abstract all this complexity and let application developers write application in such a way that they are portable, they run, basically depict the main business logic of the application, and being able to like run on different and not care about the platform on there which are running. So this is the problem statement as of now. Applications are requested to know a lot of details of underlying hardware, and capturing frames, meaning like you have to really know about the what peripherals you have on the hardware and configuring it before the application can even use it. And yeah, the media graph that I showed you earlier is from like 10 years back. So it was already complex 10 years back, and modern laptops that are shipping with powerful ISPs like Intel IPO3, I rather not show the media graph here because it's very complex and I just don't want to. You can look it up online, maybe, and let us know. And the details would be worried about the Libcamera developers. So yeah, this is a reply on a mailing list. Web camera not recognized by Dell Latitude, this specific model, because it was shipped with an IPO3 camera. The reply was, laptops, I will just read it out, embeds one of these new complex cameras from Intel. They require IPO3 driver. Though unlike traditional webcam, you need special user space to use it. There is no embedded firmware to manage focus, white balance, etc. User space code need to read the stats and manage that. As of now, there is a no good plan on how to support this as your user space. So I hope you have pretty much understood what is the problem we are dealing with here. So yeah, that was the motivation or the background for which the Libcamera has been started. It is being actively developed by Linux Media folks, and yeah, some other consulting firms as well, very specific to related to the needs. So let's get into that. Libcamera is a complete user space camera stack. It abstracts away all the complexities as we discussed about V4L2, media controller, hardware topology, everything. It aims to be compatible with already written media applications, V4L2 based application, and aims to like provide a layer so that we can it can be used on Android and ChromeOS. already we had a good amount of documentation. We have application developer and pipeline handle that we will discuss, and a couple of sample applications that we use for testing and basic dog fooding. So you can just try them out and see for yourself. Now let's, okay, we are mail-based development. I know mailing list plus patchwork. Basically, I think that's the workflow the Linux media domain were comfortable, so they started with that. We use Meson and Ninja, and it's quite like, it might sound complex, but as of this talk goes, you will find it's not a very like, I come from a background where I haven't done much Linux development. Mostly I was working in user space, but the community and people are very friendly, very newcomers friendly. So I think if you plan to contribute, please check it out. Let's talk about complex cameras debate. There are a couple of, if you want to get more into the problem space, specifically the problem space, so why embedded cameras are difficult and like complex cameras on Linux, these are the 3 talks I would recommend. You can check them out simply searching for them on the YouTube. They are a personal favorite of mine and basically help this talk that I'm delivering right now. Okay. Okay. So here is the entire camera stack, a bird's eye view. So you can see the kernel space already has like a media device, video device, and B42 subdev. The Libcamera will interact and abstract all of this for applications. We have a V4L2 compatibility layer, so existing application can work on it. We also have GStreamer element that it can use. We, as of now, don't have language bindings, but there is, I think, a discussion going on, and we would start with Python. So basically, just to mention, Libcamera is being developed in C++. So I think for now, C++ would be a strong association if there is any application wants to use it. But yeah, shortly you should look out. There's a plan already planned for language bindings, and we also have a Android camera a hardware abstraction layer, which is which sort of decently works on the ChromeOS as well. So this is the bird's eye view for Libcamera. And now I think we will go into Libcamera architecture. So at the top is the public API, which the applications will interact. At the core, Libcamera has a device manager, which will start and enumerate. It will find all the camera video capture devices attached to your systems and expose camera device objects that you can use. We have state machines, so basically to track what is the status of the camera, it's running, it's stopped, or it's in configured state or something like that. We have streams, what streams are supported by the camera, what role do you want to use for video capture, or you want to use for a still capture. So depending on that, the camera device will give you best suited streams and at which an associated resolution. And you of course have access control so that no 2 applications simultaneously asks for the camera at the same time. So this part is device agnostic. This has nothing to do with the underlying hardware, and all the device specific stuff goes into a pipeline handler, which will do all the things, video nodes, media controller stuff, and set up pipelines, set up the flow in which the data flow was intended to be, because you have different, like Rockchip would have a different pipeline handler and rather than a Raspberry Pi one. So you will have a Raspberry Pi pipeline handler, and will have a different Rockchip pipeline handler. So all the device specific stuff goes here. And the device manager is smart enough to figure out what the platform is and use the appropriate pipeline handler. And mind you, like pipeline handlers are a bit complex in a way, like camera objects can be different, but they can use the same ISP on the hardware. So no two cameras one will gain exclusive use of the pipeline handlers. Another thing is image processing algorithms, which is also very device specific. And this is shown in a blue kind of box, which shows the sandboxing, because image processing algorithms, or 3As as we talk, are very vendor specific, and vendors might need to protect that core IP. So Libcamera already has been developed with that frame in mind. So we are LGPL, Libcamera is LGPL, so that we don't tie into some binary blob in the future. So it has been designed in such a way, and you have some helpers and support graph, buffer allocators, pipeline runners, and debugging and logging, which are, I think, if you plan to develop these, will become obvious if you read the documentation. Yeah, so platforms supported by Libcamera as of now, we have UVC, like your USB webcams. IPU3 is supported, Rockchip, WIMC, which is a test driver, and we do a lot of testing, like for if we don't have some hardware or something. And for Raspberry Pi, we also have working with Raspberry Pi folks for the support in Libcamera. Libcamera API. So let's talk about something which is the core of this talk. I want to just give an overview how the API and how would application would interact with Libcamera. So basically 5 things. We have camera manager, we talked about a little bit, which will do the camera enumeration, which will find all the devices attached to your system. Then we have camera configuration, which will just set up the camera, prepare it for the intended use. We have config validation, like if the application has specific requests, suppose an application wants to capture a specific format or a specific capture at specific resolution, the application can request it through the configuration, and it will be sent back to the camera for validation. After that process happens, it's just allocating some buffers for the data being written. And finally, we have the frame capture. So let's try to map it out a bit into the code. Yeah, camera enumeration, camera manager. We make a new camera manager. We start the camera manager, which will like set up pipelines, find all the devices, and make camera objects. And you can retrieve the camera from camera managers with the cameras API. We just iterate over them and we just print an ID. So camera enumeration. Let's talk about camera configuration. After we have got the cameras, we select the first camera we have. So 0 is the first camera, suppose. We get a pointer to it. we acquire a camera. So this is an exclusive lock. Once a camera has been acquired, no other application will be granted access to that camera for the time until it is released. So after the camera has been acquired, it is just we would generate a configuration, and for the configuration we specify a stream role. Stream role is basically what's the intent of the use. So basically you can tell it's a still capture, or it's a raw capture, or it's a video capture, or something else. So accordingly, the camera will generate a configuration and store it in config. Now comes the validation part. So after a configuration has been, camera configuration has been stored, so what it contains is a stream configuration. So stream configuration is nothing but a specific configuration for each stream role. Like you can ask for multiple stream roles or other stream roles. So each will have a specific stream configuration, and you can suppose this is the stream configuration the camera has given you, and default still capture configuration. So this is the default one. So if I print this out, it will tell me it will capture at 1280 720p resolution with the format being MJPEG. And let's say I'm not satisfied with this configuration, so I can I as an application developer can write, let's see, I will give, I want to capture at width 640 and height 480. So I will just try to amend these two parameters, and again I will try to validate the config. So what happens here is if the camera can provide this resolution, it will just simply validate it. If it doesn't, it will give the nearest configuration. So suppose if this is not supported, then a lower one is supported for suppose 320 into 180. So it will just try to amend this and give you 320 and 180. Or similarly, or if you go higher, it will try to get it, but if it doesn't have, it will just keep it as default. Sorry. After the configuration phase has happened, we will just allocate some buffers. So you can use your own allocator, or Libcamera provides one for you. It's a frame buffer allocator. It will iterate over the stream configuration. You can, like, a camera can ask for multiple streams, as we talked about. So basically, I can ask for a stream where I want to look at the camera is just streaming all the frames, but I want, at a click of a button, I want a frame to be saved to a disk. So camera can ask for like something like NB12 and MJPEG. So NB12 will just keep the stream going on in my application window, and when I hit like capture, it will just use the MJPEG stream and capture that frame in MJPEG and save it to the disk. So in a way, like, application can ask multiple from the camera itself. So for each stream, you have to allocate buffers. So we would iterate from the configuration. We would iterate on each stream configuration and allocate buffers. It simply allocates like required number of buffers it thinks it can, but I am sure you can specify your own set of requirements as well for the buffer allocation. Now comes the frame capture part. So after allocating buffers, you can create a request to the camera where request is at least one stream, like one stream from the stream configuration and the frame buffer you have got like from the previous slide. So request is nothing but one stream, one buffer, and you just queue it to the camera. After after the requests are queued to the camera, you just run camera start, and it will start writing data to those buffers. And after like, how do you know like when the buffer is full? Because you will know when the camera has emitted the request completed signal, and thereafter in the signal handler you can just go and take out the buffers from the request object, and simply you can just do like your frame capture is then complete. Libcamera sample applications, we use a cam utility, which is a Swiss knife. It's a testing tool. It has got all the configuration options. We have QCam, Qt-based Q GUI application. We also have simple cam if you just want to read like the minimal reference code as we did just right now. So you can just look at the simple cam and try running it. And reading it's over commented, so you will have a good grasp on how to write a application with Libcamera. There is decent documentation and app developers guide in the tree itself. You can also look into that. So yeah, please join. Libcamera is a young project. It started around 2018 maybe. Yeah, I'm not sure, but yeah, somewhere around 2018. Docs, patches link. We have a IRC channel, Libcamera on Freenode, and we welcome inputs from anyone working with cameras. I think that's all from me, and I guess I can take questions now.
Hi, thank you for your talk. We have a few questions for you. You can check those at the shared node section here in the big blue button.
Yeah, I see the questions. Will it be possible to use IPU cameras from V4L2 then? Yes, I think so. It can be used, but V4L2 you will also have to tackle the media controller API from the kernel itself, and is it to be done with fallback devices? I'm not sure I understand what you mean by fallback devices. Does it interact with tools like GStreamer? Yes, we have element GStreamer element, and I think there's good support because it was written by GStreamer developers. So, and Pipewire, I think there is some work in progress going on regarding Pipewire. So basically, as far as I know, Pipewire likes to ask the system resources upfront. But Libcamera, what it does, it allocate resources on the fly. So there is like some bit of mismatch that we don't have like a robust support as of now. But I think there was a discussion on the mailing list as far as I know. So it's still, I think some people will bash their heads on it as well. Will Chromium Firefox support this? I hope so. Chromium, we are working with Chromium developers for Chromium OS. So that's the first part to make it work there. And I hope if you have like in the Chromium OS, there's like it goes into as a shared library. So if you just replace it with what Chromium OS ships, the browser, the native camera app will start using Libcamera. So yeah, I'm not sure of Firefox as I have not been actively engaged in Firefox development.